Today we are going to discuss some of the problems on periodic and non-periodic signals. First problem, determine whether or not each of the following signal is periodic or not. If periodic, find its fundamental period. First problem, x of t is equal to e power j pi into t. We know that x of t is equal to e power plus or minus j omega naught of t is periodic with period t is equal to 2 pi by omega naught. Therefore, x of t is equal to e power j pi into t is periodic signal. Then comparing e power j omega naught t, we have pi is equal to omega naught and t is equal to 2 pi by omega naught, which is equal to 2 pi by pi, which is equal to 2. Next problem, x of t is equal to e power at. Then x of t plus t is equal to e power a into t plus t, which is equal to e power at into e power a into t, which is not equal to x of t, because e power at is equal to 1 when a is equal to 0 or t is equal to 0. Therefore, x of t is equal to e power at is non-periodic signal. Next, x of t is equal to cos of phi u pi t. Then x of t plus t is equal to cos of phi u pi into t plus t, which is equal to cos of phi u pi t plus phi u pi into t. When t is equal to 2 by 5, then x of t plus t is equal to cos of phi u pi t plus 2 pi, which is equal to cos of phi u pi t, which is equal to x of t. Therefore, the given signal is periodic with period t is equal to 2 divided by 5. Then x of t is equal to sin phi u t. Then x of t plus t is equal to sin of 5t plus t, which is equal to sin 5t plus 5t. When t is equal to 2 pi by 5, then x of t plus t is equal to sin 5t plus 2 pi, which is equal to sin of 5t, which is equal to x of t. Therefore, the given signal is periodic with fundamental period t is equal to 2 pi by 5. Next problem, x of t is equal to e power sin of t. Then x of t plus t is equal to e power sin t plus t, which is equal to e power sin t, which is equal to x of t. This is for t is equal to 2 pi. Hence, the given signal is periodic with fundamental period t is equal to 2 pi. Next problem, x of t is equal to t into e power sin of t. Then x of t plus t is equal to t plus t into e power sin of t plus t, which is equal to t plus t into x of t for t is equal to 2 pi. That is, x of t plus t is equal to t plus t into x of t for t is equal to 2 pi. Hence, the given signal is non-periodic. Next problem, x of t is equal to 3 plus t square. Then x of t plus t is equal to 3 plus t whole square is equal to 3 plus t square plus 2t into t plus t square, which is not equal to x of t. Hence, the given signal is non-periodic. Next problem, x of t is equal to cos of t plus pi by 4. Then x of t plus t is equal to cos of t plus pi by 4, which is equal to cos of t plus pi by 4 when t is equal to 2 pi. Then the signal is periodic with t is equal to 2 pi. Next problem. Determine whether the continuous time signal x of t is equal to x1 of t plus x2 of t plus x3 of t is periodic where x1 of t, x2 of t and x3 of t have fundamental periods of 4, 1.25, root 2 seconds respectively. Given T1 is equal to 4, T2 is equal to 1.25 and T3 is equal to root 2 seconds. Then T1 by T2 is equal to 4 by 1.25 which is equal to 16 by 5. This is a rational number. Then T1 by T3 is equal to 4 divided by root 2 which is an irrational number. Therefore, the signal x of t is non-periodic. Determine whether or not each of the following signal is periodic or not. If periodic, find its fundamental period. First problem, x of t is equal to cos of 5 pi t plus sin of 6 pi t. Then omega naught is equal to 5 pi. I am going to consider omega naught 1 and omega naught 2 as 6 pi. Then T1 is equal to 2 pi divided by omega naught 1 which is equal to 2 pi divided by 5 pi which is equal to 2 by 5. Then T2 is equal to 2 pi by omega naught 2 which is equal to 2 pi divided by 6 pi which is equal to 1 by 3. Then T1 by T2 is equal to 6 by 5. This is a rational number. Therefore, x of t is periodic. Now we have to find what is the fundamental period. Then T1 divided by T2 is equal to 6 by 5 which is equal to 6 divided by 1 into 5 I can write. Then LCM of 1 and 5 which is equal to LS5. Therefore, fundamental period T is equal to T1 into L which is equal to 2 divided by 5 into 5. The answer is 2. Next problem, x of t is equal to cos of pi by 4 t plus sin t. T1 is equal to 2 pi divided by pi by 4 which is equal to 8 and T2 is equal to 2 pi divided by 1 which is equal to 2 pi. Then T1 by T2 is equal to 8 divided by 2 pi, which is equal to 4 by 5. It is a irrational number. Therefore, x of t is non-periodic. Next, x of t is equal to cos of root 2 times of t plus cos of t. Then t1 is equal to 2 pi by root 2, which is equal to root 2 into pi. T2 is equal to 2 pi by 1, which is equal to 2 pi. Therefore, T1 divided by T2 is equal to root 2 times of pi divided by 2 pi, which is equal to 1 by root 2. It is not a rational number. Hence, x of t is non-periodic. Next problem, x of t is equal to 10 times of cos pi t into sin of 4 times of pi into t, which is equal to 5 into sin of 3 pi t plus sin of 5 pi t. This is by applying sin A cos B formula. Then T1 by T2 is equal to 2 pi by 3 pi, which is equal to 2 by 3, and T2 is equal to 2 pi by 5 pi, which is equal to 2 divided by 5. Therefore, T1 by T2 is equal to 5 by 3. It is a rational number. Hence, x of t is periodic. Then T1 by T2 is equal to 5 divided by 3. I am going to multiply it by 1. Then LCM of 1 and 3, which is equal to L, is 3. Therefore, fundamental period T is equal to T1 into L, which is equal to 2 by 3 into 3, which is equal to 2. Next problem, x of t is equal to e power minus j 10t plus e power j 15t. Then t1 is equal to 2 pi divided by 10, which is equal to pi by 5. t2 is equal to 2 pi divided by 15. Then T1 divided by T2 is equal to 15 by 10, which is equal to 3 by 2. This is a rational number. Hence, x of t is periodic. Then LCM of 1 and 2, T1 by 2, T2, LCM is L is equal to 2, then T is equal to T1 into L, which is equal to pi by 5 into 2, which is equal to 2 pi divided by 5. Next problem, x of n is equal to e power j 7 pi n. Determine whether the following discrete time signals are periodic or not. If periodic, find its fundamental period. So first one, x of n, which is equal to e power j 7 pi m. Comparing with x of n is equal to e power j ohm naught into n, then ohm naught is equal to 7 pi, which is equal to 7 by 2 into 2 pi. That is m by n is equal to 7 by 2. This is a rational number. And it is periodic with period n is equal to 2. Next, x of n is equal to a into cos of 3 pi n. Comparing with x of n is equal to cos of ohm naught of n plus 5. Ohm naught is equal to 3 pi, which is equal to 3 by 2 into pi. Therefore, m by n is equal to 3 by 2, which is a rational number. Then the given signal is periodic with fundamental period n is equal to 2. Next problem, x of n is equal to cos of 2n. Comparing x of n is equal to a cos of ohm naught of n plus 5. Ohm naught is equal to 2, which is not equal to m by n into 2 pi. Therefore, the given signal is non-periodic signal. Next problem, x of n is equal to 3 into e power j 3 by 5 into n plus half, which is equal to 3 into e power j 3 by 10 into e power j 3 by 5n, where ohm naught is equal to 3 by 5, which is not equal to m by n into 2 pi. Hence, the given signal is non-periodic signal. Next problem, x of n is equal to 3 into e power j 3 by 5 pi n plus half, which is equal to 3 into e power j 3 pi by 10 into e power j 3 by 5 pi into n. Then ohm naught is equal to 3 by 5 pi, which is equal to 3 by 10 into 2 pi. Therefore, m by n is equal to 3 by 10, which is a rational number. Therefore, the given signal is periodic with fundamental period n is equal to 10. Next problem, x of n is equal to 5 sine 7 pi by 12 n plus 8 cos 14 pi by 8 into n. where ohm naught 1 is equal to 7 pi by 12, which is equal to 7 by 24 into 2 pi, or m by n1 is equal to 7 by 24. This is a rational number with n is equal to 24. Similarly, ohm naught 2 is equal to 14 pi by 8, which is equal to 7 by 8 into 2 pi, or m by n2 is equal to 7 by 8, which is a rational number and it is periodic with period n2 is equal to 8. Then LCM of 24 and 8 is 24 itself. Then fundamental period n is equal to L is equal to 24. Next problem, x of n is equal to real part of e power j by n plus e power minus j pi by 3n, which is equal to real part of cos pi n plus j sin pi n plus cos pi by 3n minus j sin pi by 3n, which is equal to cos pi n plus cos pi by 3n, because it is given only the real parts. Then ohm naught of 1 is equal to pi, which is equal to 1 by 2 into 2 pi. Then m by n1 is equal to half, with fundamental period n1 is equal to 2. Then ohm naught 2 is equal to pi by 3, which is equal to 1 by 6 into 2 pi, or m by n2 is equal to 1 by 6. Then n2 is equal to 6. Then LCM of 2 and 6 is 6. Therefore, fundamental period n is equal to L is equal to 6. Next problem, x of n is equal to cos of n by 4 into cos of pi by 4 into n, where ohm naught 1 is equal to 1 by 4, which is not equal to m by n into 2 pi. This is non-periodic. And ohm naught 2 is equal to pi by 4, which is equal to 1 by 8 into 2 pi. Therefore, m by n is equal to 1 by 8. It is periodic with n is equal to 8. But product of periodic and non-periodic signal is non-periodic. Therefore, x of n is non-periodic signal.